All right, no, it's fine. So in this lesson, we're going to apply the laws of exponents to rewrite expressions with radicals and rational exponents. Now you might think to yourself, Mr. Adams, what the heck are rational exponents? Well, in regular, normal, everyday talking, rational exponents are powers with fractions. So 49 raised to the 1/2, this is what we would call a rational exponent, okay? 36 to the 1/2, rational exponent, because we're raising the power to a fraction. All right, and I'll explain what that means in a second. There's a rule. If we go way down here, the rule is this. This is what we call the index or the root. And so the index or the root goes here. That means I'm taking the second root of 49. Now the top number, the numerator of the fraction, is the power. So it's 49 to the first power. Well, let me say it the way that it is. It's the second root of 49 to the first power. I could rewrite any rational exponent as what we call a radical. This is called a radical. Now, we all know that the second root of something is just the square root. So the square root of 49 is just 7. Why is that? Well, because we know that 7 squared is equal to 49. So if I take the square root of 49, I'm going backwards 7. Okay? Now let's look at that for a second time. I know some of you guys probably didn't get all that written down. I'm going to come back in a second. So if I say the 36 raised to the 1/2, what I'm really saying is the square root, the second root of 36 raised to the 1. Or we can think of that in terms of just being the plain old square root of 36. Well, what number do I square to get 36? 6. Okay. Now this next one's just a little bit trickier. I want to take the cube root of 27. Or 27 raised to the 1/3 root. Now you can plug this in your calculator and it'll give you the answer. But you don't need a calculator for this. In other words, I'm going to take the 3rd root of 27 raised to the first power. Well, what you may not know off the top of your head, that 3 cubed is equal to 27. Therefore, 27 is the same as 3 cubed. And when you take the cube root of a cube, the cube and the cube root are like inverse mathematical operations. They undo each other, and you're left with 3. Okay, so that's just like kind of a warm-up to kind of get you guys. I'm going to explain it in greater detail in the next couple of examples, but that's what we're working on. Okay? Any questions so far?